Hello, Marauders, and welcome back. Here I am at the North Pole enjoying the weather, and there's flamingos, a snow flamingo, I guess. Okay, but anyway, welcome back. We're going to be starting geometry for the next couple weeks. If you've been doing the statistics unit, I will have a test available for that on Friday. So if you've studied it and you say, hey, I know some statistics, I want to earn some points, Friday the test will be available. If you were gone, you can go back and look at those videos. If you don't want to do the test, you don't have to. But anyways, let's learn some geometry. Geometry, in fact, is one of my favorite math subjects because you see it all around. Everywhere there's shapes. If you play with Legos, you're doing geometry. If you're doing construction, that's geometry. If you're a plumber, that's geometry. You're putting things together. So let's check some of it out. Okay, so chapter 7 from the book, and all these slides are available under slides, and this will be day 1. There's a lot of neat stuff in here, and hopefully it'll make you look at things in a different way. We won't get to all the fun stuff because so much of this is interactive. But here's the first page, which there's like hundreds of vocabulary words, and I have flashcards in class that we won't be able to see. You can read this. You can pause the video whenever you want. I'm just going to go to the next page. And you could read this, pause the video. I'll go to the next page. And here's some questions. By the end of this investigation, you will be able to answer questions like these. What is a line of symmetry? What is a prism? Okay, so here's the first thing. And I like to make geometry a lot of fun. So here's a hole in the ceiling. It says the roof of the Pantheon in Rome is a dome with a round opening called an oculus. See, there's all these neat geometry words you may have never heard of, but that's a hole here in the ceiling, okay? A round opening is an oculus. 29 feet in diameter. That's a pretty big hole. Describe the shadow as the light comes through. Now the light's going through a circle, but what shape is the shadow? Go ahead and pause and think about it. All right, well, you probably said a circle. That's probably correct. But is it always a circle? Let's check this out. Okay, so here's a flashlight, and it's shining a circle, but if the light comes at us sideways, like at an angle, it's now an ellipse or an oval, but we call it an ellipse. So you might not get a circle, you can get a different shape. Circle, ellipse. So right here is like a spotlight. Imagine there was like an ice skater or a dancer here. And there they are, so it makes like an oval. Okay, next page. So visualize a square casting a shadow on a floor wall. Can the shadow be non-square? So here I've made a square and a shadow. I'm sorry, the flashlight is shining on the square. Will it have a square shadow? Pause the video and think about it. Okay, could it be not square? Could it be not rectangular? In other words, can the measures of the shadow's angles be other than 90? And what is 90? Well, when you have a perfect corner, so if I drew something like this, these little areas here, these are 90 degrees, perfect corners. Okay, so let's see what happens. So here I have a square, okay, and I'm going to shine, is the shadow a square? I'm shining a flashlight, a lot of glare, there's a square, but could this shadow be a rectangle? Well, if I turn this, depending on how I turn it, I can make it look like a rectangle. Now it's small. Here's some other things I could do. Depending on how I hold this, I could get a rhombus or a parallelogram. So it's kind of hard to do this, but as I do this at different ways, I could get things that aren't quite square. In fact, if I were to trace that, those corners are not 90 degrees. I don't have a third hand, but I could get a parallelogram. Are the sides always parallel? Do they have to be 90? If I move in a little closer, I can make the sides kind of bow outward a little bit. It's hard to tell here. I'm trying to get this just right. And I can make this not quite 90, where it's like, hey, it looks more like a trapezoid. The top and bottom are parallel, but not the sides. So, but it always has four sides, or as we call it, quadrilateral. So even though I've got a square, I can get different shapes, but it will have four sides. It always has four sides. What about this? An equilateral triangle. There's another word, equilateral. Equal and lateral means side. So equal sides. But can you get a circular shadow? I don't think so. Let's go to the next one. Okay, when you fold a figure in half so the two halves fit exactly on top of each other, the shape is symmetric. The line that contains the fold is a line of symmetry. So symmetric means both sides are the same. Like our bodies, our left and right are the same. A line of symmetry is where you would fold it. In other words, you look at these little drawings like this arrow, I go right through there. The left and the right are the same. Or I could go right through here. The top and bottom are the same. Each one of these, there's a line I'd fold it. Like if I'm making a paper airplane, where would I fold it? So each side is the same. And if I fold this over, it matches up. So, for example, how about the first letter T? Here's the letter T. I could fold it right through the middle. The horizontal line to the second T is not a line of symmetry. So this is a vertical line right here, going straight up and down. So I could actually just fold this onto here and it would match up. But this way, no, this doesn't work. That's the top and bottom. That doesn't fold onto that. Okay, so what other letters are symmetric? So let's just use capital letters to not confuse us. Which letters are both horizontally symmetric and vertically symmetric? So in other words, like this is the letter T, he folded it this way. And this guy's like, ugh, he's not really getting that right. So remember vertical line, here's vertical line, straight through the middle. Horizontal, like the horizon, that way. Some things like this square could go both ways. And G doesn't have anything. Okay, so pause the video, try to draw lines through each one of these shapes. Which ones are vertical? Which ones are horizontal? Which ones are both? And which ones are neither? Okay, pause it and try it. Next slide, I'll show you the answers. All right, I'm gonna flip. Here's the answers. And you can see them all. And there might even be some diagonal lines, but they didn't put them in. How about a circle? Describe the lines of symmetry of a circle. That's not a circle. So if I want to do a circle, there's a circle. Where would the lines of symmetry be? Well, is there a horizontal line? Oops, I kind of missed. It's not easy to do this. Yeah, I could go that way, and I could go this way. Is that it? I could go this way. Oh, I could go this way. Wait a minute. I could do an infinity amount of lines. As long as I go through the center, I could keep going. Here's a car. I fold it right, no, I don't fold it right there. I should fold it right there. Okay, the top and bottom are the same. Okay, for you to do, I need a volunteer. Who wants to volunteer? Come on up and finish this drawing. Here's half of it. Use your finger on the screen and try to draw this in, counting the dots. Normally I'd have somebody come up to the board and do it. I'm not doing a very good job. We'll try it again. Here, here, and just keep going. You fill it in. All right. Pause whenever you want. Next slide. Construction and buildings and mankind, womankind likes to make geometry in their art. This first drawing over here is looking upward. And you can guess which country this is in, but it's an interesting type of art. Well, it tends to be a Islamic pattern. Middle Eastern, they love to use geometry in their art as kind of their glorification. How many lines of symmetry are there? How many ways could you fold this one? And how about this one over here? Okay, pause it. Okay, we're back. Let's see, I could fold this. Well, let's do the building. Well, it looks like just right through the middle. Left and right are the same. But this one, let's see. Some of you said I could fold it right there. I could fold it there. That's 2. Oh, we lost our picture. Okay, I lost it again. 3, is that it? No, wait, there's more. Did you do this one? 4, 5, 6. There are 6 lines of symmetry. After all, it's a hexagon. Next slide. Well, there's the Capitol building. And what do you notice? Hey, it's even got symmetry, doesn't it? Okay, check it out. The walkways, even where they put the flowers. Things you might not have realized, they like to do symmetry. Every little thing, this little thing's here, this little thing's here, a little cupola, and everything matches. Even the people are standing, no, I guess the people aren't standing that way. Yeah, there's a law that says you have to stand symmetrical. Uh-oh, what's not symmetrical? There's a flag. Oh no, we're missing the flag over here. Okay, in addition to line symmetry, some things have radial symmetry. Radial, it means like circular. So some things, in other words, instead of flipping them, can spin. Some or both. Like if I look at this starfish, of course, I could fold it and say it's got a line of symmetry here and here and here and here and here. But in addition, you could rotate it like a clock. You could spin it and it would look exactly the same. If I were to take this drawing and turn it just a little, you probably couldn't tell. That's called radial symmetry. If you were to spin it, it's like, is it upside down now? Well, I don't know where upside down is. It doesn't really have an upside down. That's radial symmetry. Which ones on here have radial symmetry? Well, the starfish. How about the flower? If I spun the flower, you couldn't tell. It would just look the same. So we also got, we got this, and we've got this fruit that can spin. Even this flower, it's got radial, this snowflake. You could say maybe, no, we're not gonna really say 180. But we can also do our lines of symmetry, like this butterfly right through the middle there. This and this one, you could go like this, this, and this. And I keep losing it when I go off the screen there. And 3. This one's got a line of symmetry this way and this way. This leaf just has 1. The snowflake has 6. Okay, which of these shapes can cast a square shadow? Oh, and look, here's our homework. Page 559, 1 to 11. Guess what? You're already on number 5. You just did the first 4. You get to do the rest. So each slide I'll give you some instructions. You can also see them in the book. It says, which of the shapes below can cast a square shadow? So if I held a square, obviously I can make a square shadow. But could these other shapes make square shadows? Think about it backwards. When I held the square, I was able to make some of these other shapes. I made a rectangle, I made a parallelogram. If I can make like a rectangle, I should be able to go backwards and take a rectangle and make a square. So of all these shapes, which ones can you make a square shadow? Okay. And by the way, do you see any parallelograms? What's a parallelogram? Something that has parallel lines and the opposite sides are parallel. But usually we think of it like this. Like this. But the edges are parallel, and the top and bottom are parallel. That's a parallelogram. This is not a parallelogram. Next slide. I'll show you all the answers tomorrow. Here's number 6. Classify each quadrilateral. Quadrilateral. What's a quadrilateral? Quad means 4, like a quad runner has 4 wheels. And once again, lateral is side. So these are all quadrilaterals, anything with 4 sides. Of course, there's lots of things like squares, rectangles, but there's all types of quadrilaterals. What you're going to do is try to draw as many lines of symmetry as you can. How many can you do? You'd be surprised. Like, how many does a square have? How many places could you fold the square that it works? Can you fold the parallelogram? Where would you draw the line of symmetry? Some people make it dash. Where do I, Some of these might be impossible. So you draw as many lines of symmetry as you can for each drawing. Once again, tomorrow I'll give you the answers. Pause if you want to do it. I'll go to the next slide. Number 7, shine a light directly down on a triangle. Here's a flashlight, and we shine on a triangle. Here's a picture of someone doing it over here. What properties of the triangle and the shadow are the same? What is different? In other words, when you look at the shadow and the triangle, what about them is the same and what is different? That's number 7. Next slide. Okay, this is interesting. This goes for the last 4. New thing, more vocabulary. A polygon, and we've just lost what we have, okay. Okay, a polygon. What is a polygon? A polygon is a closed shape with straight sides and no curves. In other words, looking over here, these are polygons. The sides are straight, there's no curves, and it connects, it's closed. In other words, wherever you start, when you draw it, you go back to where you start. These ones down here are not polygons. Why? Well, it looks like somebody like they started to draw it and they didn't finish. You got to get back to where you started. This thing's not even closed in. You got to be able to color it in, and it can't be round. So straight sides, no curves, and it's closed. Here's some more down here. Examples of polygons. You can color them in. This one's got 2 parts. That's no good. This one's roundy. You can't be roundy. And somebody didn't finish this. If they closed it, they would have been good, but they missed a piece. Okay, something new. A grid polygon. This is your challenge here. A grid polygon is a polygon that's drawn on the graph paper, and you follow the lines. So in other words, you can't go like that. Of course, you can't curve anything. So here's some grid polygons. Each one of these is drawn on the graph paper following the lines. 3 of the 4 figures are grid polygons. Who messed up? Who went off the lines? Well, this one. You can't go diagonally. For a grid polygon, we're trying to stay on the grid, on the lines. Which 2 are the same? Well, you should have picked, well, it says B and D. B and D are the same. In fact, and how many squares? This one's 5 squares. 1, 2, 3, 4, 5. This one's 7. 1, 2, 3, 4, 5, 6, 7. Okay. And did you notice that D and B are the same? It's just rotated. So it's not really unique. In fact, this one looks like a dog. If I put a little smile on there, there's his eyes. That's supposed to be his mouth. Here's his tail. Try to go like that. Okay, so yeah, here's like a tail. There's a smile. See, he's like a dog. This is the dog too. He's just kind of sideways. There's a smile on his eye, and here's like his tail. Okay? So this is actually the same one. So if you rotate it or flip it or spin it or turn it around, it's still the same one. Okay, so here's your challenge. For number 8, 9, 10, 11, draw as many different grid polygons as you can that enclose the given number of squares and have at least 2 lines of symmetry. So in other words, draw, like you can use some graph paper, use 4 grid squares. Okay, so draw some with 4 grid squares. So maybe I'll go like, here we go. Boom. You gotta stay on the lines. Boom. Here, here, here. I'm trying to stay on the line. It's not easy on here. Okay, that's 4 squares. Right, 1, 2, 3, 4. Oh no, does it have 2 lines of symmetry? Wait a minute. where do I can't fold it there. No, can't fold it there. Here, wait a minute. Here, no. This one's no good, right? I got to come up with something that has at least 2 lines of symmetry. In other words, I can fold it 2 different ways, and I got to use 4 squares. Then try to do something with 5 squares, 6 squares, and 7 squares. There's more than one way to do these. Come up with as many as you can. Tomorrow I'm going to show you the answers. I'm going to give you a hint. I came up with 2 unique things. You can't just draw the same thing and then just spin it, okay, or rotate it. That has to be unique. And this I came up with 2. And this I came up with 2. And this I came up with 4. Here's your challenge. Can you come up with them? And that's the end. So you do the homework. Tomorrow I'll come back with the answers. Enjoy. Okay, so do all the homework on your own. You won't be able to turn it in to me, but tomorrow when I show you the answers, you just check your own. There will be some things that I will actually have you submit to see if you're keeping up to date. But after we get through all the slides, we will have a test on it.